Okay, so we should have watched a video over asymptotes and exponential functions, and then we should have done page 329, 1 through 7. I'm just going to walk through the answers, so hopefully we are certain that we've got everything right. All right, so number 1 on 329 says to graph. All right, so if I just look at this one, all right, so our initial value is 6, our growth factor here is 1.2, we have an exponent of x. All right, so that one, if I plug in 0 for x, 1.2 to the 0 is 1, and then 1 times 6 is 6. So this one is going to be growing. It's going to have a y-intercept at 6, and it's going to be coming along here, and it's going to be going up. All right, this one is very similar. If I plug in 0, so 0.9 to the power of 0 is 1, 1 times 6 is 6. So again, we have a y-intercept at 6, but this one is decreasing. All right, so 1 is going up, 1 is going down. All right, number 2, determine the domain. So domain, left, right, this one's going to go left to negative infinity, and it's going up to positive infinity. So the domain is from negative infinity to infinity. Same thing for this one. It's going left to negative infinity, and it's going right to positive infinity. All right, range. All right, this one, okay, it ends up having, it goes up to the top right, so it is going to go, it's going to end up going to infinity. But left, it doesn't go down to negative infinity. It levels off here, and it has an asymptote at 0. This one is going off to positive infinity on the y, and it comes down and levels off at 0, from 0 to infinity, both of them. All right, so range is y, and so this is from 0 and up. This one's from 0 and up. All right, number 3. Describe each function as increasing or decreasing. All right, and so it's just like we read. We read from left to right. So from left to right, this one's going up. From left to right, this one's going down. So this first one is increasing. This second one is decreasing. All right, number 4. Describe end behavior of each function as x approaches infinity. So as x approaches infinity, y approaches, all right, so this one, as x approaches infinity, y approaches infinity. The second one, as x approaches infinity, so we're on the x here going along, y is approaching, all right, it's not approaching, it's not going down to negative infinity, y is approaching, comma, y approaches 0. It's going to get closer and closer and closer to 0, and that's actually what an asymptote is. It approaches it but does not cross. All right, and then if you look over on the right-hand side on our book, math terms, if the graph of a relation gets closer and closer to a line, the line is called an asymptote of the graph. All right, that's what's happening there. All right, we flip the page. Number 5. It says, describe the end behavior of each function as x approaches negative infinity. So as x approaches negative infinity, y approaches, all right, so this first one, so as x goes to negative infinity, so as we go left, what's happening with y is it's getting closer and closer and closer to 0. All right, the one on the right, as x approaches negative infinity, y is approaching, and it's going up to infinity. So as x approaches negative infinity, y approaches positive infinity. So it's going up to infinity. All right, number 6. Identify any x or y intercepts of each function. All right, I already did that when I did the graph, that when we plug in 0, we get 1. 1 times 6 is 6, or x-intercept is 0, 6. our y-intercept is 0, 6. And our y-intercept for this one, for the same reason, is 0, 6. We plug in 0, makes 1, 1 times 6 is 6. Alright, y-intercept, they both, or I keep saying y, x-intercept, it both approaches 0, but it never touches it. So it never is going to cross the x-axis. Right, it's never going to touch the x-axis. So there's not going to be an x-intercept. So x-intercept is equal to none. X-intercept is equal to none. And you could write in here that that is equal to the y-intercept. Hopefully, the way in that point form, hopefully you recognize that x, y, that is the y-intercept. But if we're going to be a little more obvious, go ahead and label it as the y-intercept. Alright, number 7. Consider how the parameters of a and b affect the graph of the general exponential function. Use a graphing calculator to graph f for various values of a and b. Alright, so when does the function increase? So 7a. When does the function increase? Alright, so it increases, if we've gone through and done this, alright, for a's must be greater than 0, and for b's that are greater than 1. This one we'd already talked about. We talked about this last time. That, you know, if the b is greater than 1, that generally describes an increasing function, but all of the ones we did last time had a's, we only did positive a's. Okay? And we're going to have to look at, well, what happens when you have a negative a? Right? Obviously 0 would mean the whole thing would be 0, so you couldn't have one that's equal to 0, but one that's negative will change it up. Alright? So if you have a that's greater than 0 and b that's greater than 1, so if both of those are true, alright, it's going to increase. The other way that it can increase, so this one is one way that it will increase. The other way that you can make the graph be increasing is when we have an a that is less than 0, alright, so a negative a, and a b that is less than 1 and greater than 0. So this is a fraction or a decimal. This is what we've been, you know, like what we had on our example up above, 0.9. Alright, so that would be a b that is less than 1 and greater than 0. Okay, but that one was decreasing. But if it had that criteria, but if this was a negative 6, it would change, and then that one would be increasing. So these are the two different ways that we can make a function increase. All right, and go through, if you haven't, and play with both of these. Pick out some negatives for a, and do some fractions for b. All right, do positives for a, and some ones that are greater for b. Alright. Confusing that we have a and b, and then they've decided to do these with a and b. Why didn't we pick any other letters? But now on to b. When does the function decrease? Alright, so it decreases when a is greater than 0, and when b is less than 1 and greater than 0. So when it's in that decimal range. So this one right here is exactly this example. Alright, a is greater than 0, it's positive, and b is between 0 and 1, decreasing. From left to right, decreasing. Alright, that's the primary way that we make them decreasing. We can also make them decreasing when we have a that is less than 0, so a negative a, and b that is greater than 1. Alright, so a negative value for a, and then a b that's greater than 1. So if we took this one here, where we have a b that is greater than 1, and we made this a negative 6, alright, then it would be decreasing. Okay? Really what's going to happen is it's just going to get flipped. Alright, but go through and pick some numbers here and see what happens. Running out of paper. All right, C. All right, what determines the y-intercept of the function? All right, the y-intercept of the function is determined by A, whatever A is. State any horizontal asymptotes of the function. All right, so that's D. Y is equal to 0. All right, so for the ones we've talked about right now, all the ones we've talked about at this point have a horizontal asymptote at y equals 0. It gets closer and closer to 0, but never touches. Okay? That's it for today. We want to go through and make sure we catch up on the homework from last time, and then we need to be doing our homework for today, which is on page 330. And then, I don't remember what page, I'm looking at it now, but I don't remember what, is it 11 through 15? It's definitely at least 11 through 14. I don't remember if 15's in there. So check the Google Classroom and see if 15's included, but 330, 11 through 15, probably. All right.